Welcome to the Prompt Index, the show where we unpack the latest AI research and turn complex ideas into bite-sized insights you can actually use. Today, we dive into a study that tests whether a generative AI, specifically GPT-4o, can be a scalable educational tool for radiology residents drafting breast imaging reports. The big problem the authors tackle: radiology residents need timely, personalized feedback to sharpen their reporting, but rising clinical workloads leave less time for attendings to mentor in real time. The question: can an HIPAA-compliant GPT-4o system provide precise, actionable feedback on resident drafts in real clinical practice? Methodologically, this is a robust, multi-layer approach. The researchers pulled 35,755 resident attending report pairs from breast imaging across a single academic center, focusing on mammography and same-day breast ultrasound. From this, 3 datasets were carved out: a common error analysis set with 5,000 pairs to identify frequent discrepancies, a reader study set with 100 resident attending pairs to evaluate GPT-4o's feedback in a blinded reader study, a 15-case prompt sample set to design GPT-4o prompts with illustrative outputs. They targeted 3 clinically meaningful error types: inconsistent findings, omissions or additions relative to the attending report, inconsistent descriptions, BI-RADS lexicon and descriptor use, and inconsistent diagnoses, BI-RADS score not supported by findings. GPT-4o generated structured feedback for each detected error, and 8 human readers, 4 attendings, 4 residents, reviewed the same 100 pairs to gauge agreement, usefulness, and inter-reader reliability. Key findings are encouraging. GPT-4o showed strong agreement with attending consensus across the 3 error types: 90.5% for inconsistent findings, 78.3% for inconsistent descriptions, and 90.4% for inconsistent diagnoses, with substantial, moderate, and substantial kappa values, respectively. Inter-reader reliability was variable. Krippendorf's around 0.77, 0.60, 0.57, and replacing a human reader with GPT-4o did not significantly disrupt agreement. Importantly, GPT-4o's feedback was deemed helpful in the majority of cases: 90% for findings, 83% descriptions, and 92% diagnoses. Attending and resident responses were broadly positive, especially among less experienced readers. Significance and limitations. The study demonstrates GPT-4o's potential as a scalable, educational tool that targets real-world reporting errors and explains how to improve. Limitations include disagreement on descriptor nuances, single-center data, and the need to validate across more modalities and centers. Looking ahead, multi-center validation, expansion to other body parts, and randomized trials could establish GPT-4o as a standard component of radiology training, easing workload pressures while enhancing reporting quality. Thanks for listening. If you found this valuable, please like and subscribe to our channel. To advance your AI knowledge further, check out our free resources at the Prompt Index. You'll find the link in the description below. Until next time.